This lesson's going to focus on using the calculator to find some key pieces of the function. So you guys have actually already done this. The only difference is making our calculator window appropriate to seeing the cubic rather than seeing a parabola. So we know a little less about necessarily the terms of a function. So that could make it slightly more difficult, but we are going to be doing basically the same thing. So there's an example here that we are going to start by working on. So what we're going to do is we're going to enter this equation into the calculator, and then we're just going to try to find zeros, relative maximums, and relative minimums. So just to review that relative maximum or relative minimum doesn't mean the function actually has a lowest or a highest point, but it means it has a turning point that in that area acts like in this area, this is the highest point relative to this area, and in this area, this is the lowest point relative to that area. So we're going to find all the minimums and maximums, whether there's an absolute one or not. So I'm going to go to my calculator. I'm going to go to the y equals button and clear out anything that's in there. And I'm going to type in this equation that we're asked to find these portions for. So I'm going to type in 2x to the third power. And then plus 6x squared minus 14x plus 12. And I'm going to start with the zoom 6, seeing if I can see part of this in this window. All right, and I do see a cubic, and it appears, so I know it's cubic. This is important. I know that it has ends that go in opposite directions, and then I see that one little part sticking down here in the middle, so I kind of have an idea of where it goes, but I need to see further up. So I'm going to go change my window to see a much higher y value. So I'm going to click window. I'm going to scroll down to the y maximum because everything else kind of seems appropriate for the function, and I'm going to change it more to like 50. So this is better, but I still need to see higher. So I'm going to go back to my window, and I'm going to maybe change that to like 70. Give that a try. All right, this works. So when I look at this, I see 1, 0, one place where it's crossing the x-axis over here on the left side, and then I see one relative maximum and one relative minimum. So those are the things that I'm going to be looking for. So remember how we find these things when we have the picture of the graph is we go to the calculate button above the trace. So I go second and push that trace button, which is giving me a calculate menu. I'm going to calculate that x-intercept first, which is the 0. So I'm going to calculate the 0. And remember that every time you do one of these calculations, your calculator is doing actually a calculus procedure to estimate it. So it needs a range within to work and then like an estimation of a starting point. So we give it a left side and we give it a right side and then we give it a guess. And so we get this value of negative 4.7. So we're going to go ahead and put that in our notes, that our 0 is at approximately negative 4.7. And now I'm going to look for those relative minimums and maximums. So I'm going to do that relative maximum first. So I'm going to go second, calculate, and I'm going to choose choice 4. It's a maximum. And so again, I'm going to scroll so that I'm on the left side and press enter. I'm going to scroll to get a right boundary and press enter, and then an approximation and press enter. And so then I can see this relative maximum is at negative 2.8, 54.3. So I'm going to put that in here. And then lastly, I'm going to find that relative minimum. So I'm going to go through the same process. This time I'm going to choose a minimum. And I'm going to, again, scroll to get a left boundary, a right boundary, and an approximation. So there's my left boundary. I can get over on the right side. There's my right boundary, and then some approximation here. And so I have a minimum at 0.8, comma 5.7. So just a little review about how to find those. So the problems that you would use the calculator on are problems where the numbers just get too messy for us to do on our own, or factoring is not really an option for us. So here's an example of those. What are 3 consecutive even integers whose product is 4 times their sum? So think about first, what are consecutive even integers? You might want to call them 3 unknowns, x, y, and z. But solving an equation for 3 unknowns is extremely difficult. Can I write them in terms of each other? So think about the relationship if they are consecutive even integers. So what I know for consecutive even integers, if we think about all the integers, I'll just start with the positive ones. If you picked consecutive even integers, 2, 4, and 6 would be consecutive even integers. Notice that the difference between each of them is 2. So I know that if x is my first integer, y it could actually be thought of as x plus 2 units. Z is 2 more units than y, but we're calling y x plus 2. So really z is like that plus 2 more units. It's really 4 units away from that original x value. So all 3 of those values can be written in terms of x. And then it says their product is, so I know if I multiply them all together, that's their product, it's supposed to equal 4 times their sum. So here I am adding them together and multiplying it by 4. So these things are supposed to work out equal. So let's look at what we really have here. Over here, if I multiply 2 of these together, this would give me, and write it out if you need those steps, x squared plus 6x plus 8. And then multiplying all of that by x gives me x cubed plus 6x squared plus 8x. What's happening on the right side? Here I can combine like terms. So I have 3x plus 6, and all of that's being multiplied by 4, so that would give me 12x plus 24. And so to solve this, what I want to do is bring all the terms to the same side, much like a quadratic, so I can take a look at it and kind of figure out what my solving options are. So I get 0 on the right side, and on the left side I have x cubed plus 6x squared. The 8x and the minus 12x can combine together to make negative 4x, and I get negative 24. Now, the answers here are integers, which means this is actually a really nice polynomial, and there is a way for me to solve this without technology. But we're going to focus on the technology today, and the next lesson is going to focus on the factoring portion and how can we work with these in other ways when we want to do them with our own knowledge and not necessarily with technology. What are some of the things we should be aware of? So I'm going to go ahead and put this equation into your calculator. So I'm going to go back to my calculator. I'm going to clear out what's there, go to my y equals, clear out what's there. And I'm going to type in this new polynomial that we have, which is x to the third power plus 6x squared minus 4x minus 24. Oops. Sorry about that, guys. So lesson learned. Make sure we arrow out of that exponent and look at what you're doing, not like I was looking at my problem instead. So we'll fix this. Okay, so now we have the polynomial, but you have to know what you're doing. Look back at our paper. We want to know when this polynomial equals 0. We are looking for solutions, zeros, x-intercepts, roots, those words that all meant the same thing. We're looking for those here. So let's zoom standard and see if we can see the graph. There it is. Those are actually all of the roots because there would only be 3 of them max because I know that it's a cubic. So I'm going to work now on finding each of these possible solutions I'm going to do it once with the graph, and then we can kind of see it from the graph. So I'm going to go second, calculate, and then remember I'm choosing zeros because that's what I'm looking for here. Now notice I don't see my cursor, and I'm supposed to be finding a left bound, but look at the numbers at the bottom. They actually tell you where your cursor is. My cursor is at 0, -24. That's why I'm not seeing it in the screen. If I want to find this furthest left 0, then I'm not there yet. I'm like at the y-intercept, so I'm just going to scroll left and hope that I start seeing soon my cursor. There we go. Now I'm not going to see it again because it's too high, but it should be coming back. There it is. All right, so here's a left bound of that first 0. Here's a right bound. And just guess, I don't know, put my guess in between there too, at -6. Now again, we can kind of, I don't want to call it cheating, but we know we were getting integers here. So it looks like our answers are -6, -2, and +2. So let's take those back to our paper. -6, -2, and +2. Now these are not the 3 consecutive integers. Those aren't 3 consecutive integers. These are 3 x values. Remember what x represented for us. It represented the first number. So this actually means there's 3 solutions to this. My first integer could be -6, which means it would go -6, -4, -2. Or my first integer could be -2, which means it would go -2, 0, 2. Or my first integer could be 2, which means it goes 2, 4, 6. And you can check if these are right because you could take each group. Is their product equal to 4 times their sum? And then you would be able to figure that out accordingly.